a, a truly global academic initiative hosted by WSG University, Poland, and managed by KK Consultancy. The conference proudly reflects the spirit of global academic integration, strengthened by the presence of esteemed partners JECRC University, Jaipur, IES University, Bhopal, and the community support of Shri Karni Universe College, Jaipur. Our publication partner Springer Nature brings scholarly rigor to this initiative through its Scopus-indexed and highly reputed LNNS series. So this year we received an overwhelming response from across the globe with over 500 paper submissions after eliminating AI generated and plagiarized content and following a rigorous peer review process led by an expert panel of academicians and industry professionals. Only the top 90 papers were selected for presentation. Following this successful presentation and based on recommendations from our esteemed session chairs, these papers will now be published by Springer Nature. With that, I'm pleased to introduce our session chairs for this segment. So the session chair one is Dong Kong Trong, the in charge of MIS International School, Vietnam, National University, Hanoi, Vietnam. Sir, I would like to move forward if you want to speak some of the insightful words from your side.
Hi everyone. So my name is Duan. Okay, Pranash, can you hear me?
Yes, sir.
Yes, we can hear you, Professor.
I come from the Vietnam National University. So and currently I'm professor at the Vietnam National University. So and today I'm very happy and to coordinate the session with Professor Jacinta and Aprana. Okay, so and I think we and with you, so we have an opportunity to present this paper today. Okay, so thank you everyone.
Thank you so much, sir. And the second session chair for this session, Shikha Maheshwari ma'am, Associate Professor, Computer Applications, Manipal University, Jaipur, India. Ma'am, I would like you to share some of the opening remarks.
Yeah, thank you, Ms. Aparna. So I welcome each one of you, each participants for this wonderful conference, Nice Teas. This is again a series of the conference that I have seen from 2018. And thanks to the supporting partner also, I'm sure that we are going to have very good learnings while we are interacting over the papers. And obviously, we are also going to look forward for some of the research collaboration with each one of us, right? So in the end, I'm also going to share some of my research idea, and I would like to welcome all my colleagues, all my fellow colleagues here in this session to share their research idea, how we can collaborate further, how we can, contribute in the society, so that at least at the end of this session, though it is going to end for nice teas, but it may be a new beginning for all of us. So wish you all the best, all the participants over here. Thank you, Ms. Aparna. Over to you.
Thank you, ma'am.
Thank you so much, ma'am, for coming.
Thank you, Dishita. Glad to see you here.
Same here, ma'am. Long time. It has been long
Yes,
time.
exactly. Yes.
Yes, ma'am. So before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has only 4 to 5 minutes. Please stay within the time limit. Secondly, briefly cover your research context, objectives, methodology, key findings, and conclusion. Thirdly, a short question answer may follow your talk of 1 minute. Keep responses brief and focused. Fourthly, keep your mic muted when not speaking. And fifth, stay for the full session to support the fellow classmates and the session mates. So moving further, with the kind permission of our session chairs, we shall now proceed with the paper presentation. Ma'am and sir, should we proceed further?
Please proceed.
Okay, ma'am. Thank you so
I
much.
hope that's okay with you, Kongdin, Professor Kongdin over there. Yeah, we can proceed, right?
Okay, thank you so much, ma'am and sir. I would like to now invite our first presenter of the day with the paper title Quantum Enhanced Learning a Versatile Python Framework for Hybrid Computing Models under the paper ID 528. Uh, Sir Shravan Kumar Gaddam, I request you to please come and
Happen.
take this virtual stage and begin with the presentation. Make sure to be within the time limit. Thank you, sir.
Sure. Thanks, Aparna. Good morning, good evening, everyone. My name is Shravan. I just joined the Eastern Time Zone, United States, and my paper today is on quantum enhanced learning. Let me share my screen quickly and walk over. Let me know if you are able to see.
So we are able to see your presentation.
Okay. So my paper on quantum enhanced learning, which is on a versatile Python framework for hybrid computing models, and I've written on it. And thanks for inviting me for the conference. I'll begin with the introduction. So demand for computational power, mostly in modern machine, what we're currently learning are pushing classical CPUs to their absolute limits. And the answers have been heterogeneous computing, combining CPUs, the accelerator like GPUs. And there have been emerging trend in quantum computing, which offers transformative opportunity to solve currently in a lot of problems currently, which needs a focus currently. And the critical challenge, obviously, what I have observed or where our work needs to be addressed, and which has been effectively on bridging the gap between the classical and the quantum physics. That's a brief introduction and context on this. I'll move to the next. So the problem statement and the research gap, what I found is, despite its promise, there is significant architectural gap preventing quantum computing easy integration into standard ML, which is the machine learning workflows. So developers which lack a unified framework to manage both classical and quantum resources, they're building hybrid quantum classical models incredibly complex and inefficient. So our research directly addresses this bottleneck specifically. Go to slide 4, which has the research objectives. So we had 4 key objectives here in our research, where first was obviously the modular Python framework for hybrid learning. The second one being the variational quantum circuit as core testable components. Third being rigorous evaluate the framework's performance across diverse hardware and including CPU, GPU, and FPGAs. And finally, obviously, to establish a practical foundation for future research in quantum enhanced AI. And related work or the literature review. So our work builds on several key areas of frameworks like Crystal have already proven. The memory bandwidth advantage of GPUs, tools like Open One API and SYCL have paved the way for portable or cross-architecture parallelism. So while FPGA studies show promise in energy efficiency, they also highlight data movement challenges. So our work mostly has been on integrate quantum computing as a new class of accelerator into establishing a heterogeneous mix. So methodology and approach, what we have done or what I have done for this is a system design leverages a tile-based execution model ported from CU, DS to DPC++ to maximum memory efficiency. So the model organizes GPU threads into tiles, allowing for highly efficient and vectorized memory operation, to be specific. And to ensure portability, we migrated our CUD's implementation into Intel's DPC++ compatibility tool with manual optimization of kernel dimensioning and cross-vendor performance. And that was the approach we have done. And in the second part, with the same extension, we implemented and optimized fundamental SQL operators for each hardware target. For EGA specifically, this required obviously the specific techniques like loop unrolling and pipelining. So as you can see in the figure 1, right, which I mentioned, that you can see the joins such as producer join, consumer, kernel structure, so which tailor design is critical for optimizing data transfer and resource use on that specific architecture. I'll move to the next data and experimental setup. So for our evaluation, we use the Intel Dev Cloud for EPGAs and a local NVIDIA RTX 2080 Ti. We use the industry standard star schema, benchmark, or the SSB to test decision support queries. To ensure a realistic workload, we use a scalar factor of 20, resulting in a larger 13 gigabyte dataset with 120 million tuples. So that was the data and experiment setup I did. And the key findings or results have been, our results was definitive. On the full benchmark, the NVIDIA GPU was the clear winner, achieving a 3.5x speedup over Intel's discrete GPUs and a massive 5.8x speedup over the CPUs. We also quantified the performance portability trade-off, while native CUDs and the were about 1.9 times faster. So our SYCL implementation, which can run on multiple platforms, showed only a minor overhead. So most importantly, our full hybrid quantum classical classifier demonstrated strong classification performance, validated on the ROC curves as shown on this analysis, and providing that the framework is effective and end-to-end. And the analysis and interpretation of the findings. So what does this tell us? First, the GPU's advantage come directly from a superior memory bandwidth. Second, the minimal overload of SYCL proves it's more powerful and a viable solution for writing high performance and portable code. And finally, the successful ROC curve confirms our framework is not just a concept, it's an effective tool for building functional machine learning model that successfully integrates quantum components. As you can see in the chart, it clearly signifies the improvement.
Sorry to interrupt, sir. We are out of time. Please try to wrap it up fast.
Done. Yeah, I'm almost done, just in a minute. Now, obviously, the conclusion has been that large-scale classical workloads and building robust quantum has enhanced AI models. And the future work and limitation, quantum components were evaluated in simulators due to current hardware, and obviously there will be future work always needed where near-term quantum hardware and error mitigation techniques needs more focus on that. And there are some references. I got it. And special thanks to Intel DevCraft. And thanks if you have any concern, a question, you can ask me now. Or else I'll hand over back to you.
Thank you, sir. If any one of you have the question, you can please proceed.
So that was in brief about the research paper on quantum enhanced learning, where I use the Python framework for hybrid computing models. Thanks, Aparna. I'll hand over to you.
Thank you for your presentation. So, and I think your presentation is quite interesting. So, and I have some question for you. So, in the slide number 9, and you show the key finding. And can you explain why this CUDA outperform the SYCL? And what is the trade-off does this highlight?
You're cracking up. I'm not sure, like I mixed up something.
Okay, so and you should kind of go to the slide number 9.
Okay.
Okay, so in the slide number 9, and you show the key finding in your research.
Okay, yeah,
okay?
Sure.
So and yeah, so and can you explain why did the CUDA, the CUDA, the CUDA, and outperform the SYCL? And what is what is trade-off does this highlight?
I'm not sure what is your question here. I didn't catch up. You're asking that the native CUDA overperform portable SYCL by how much, and what exactly is it?
Yeah. Yeah.
So
yeah.
I just
yeah. Can
had
you
these
explain
findings
why?
from, so I just had findings on whatever research I currently did on this. So, and the references I provided, mostly what I found is the native CUDA outperformed many number of times whenever I did. So the existing SOSCL by, that could be somewhere around 1 or maybe close to 2. So on average, what we have found is a 1.8 or 1.9x of outperformance. So which obviously highlighted the performance portability trade-off, which we were currently looking into it. And obviously the NVIDIA GPUs and demonstrated superior performance when we did, and which achieved a significant speed up over Intel GPUs. Back to you,
Okay.
Professor.
Yes. Yeah, thank you. So, and regarding to the quantum model evaluation, so and what is the context you can apply the quantum classification model used for some classification problem? What is the context?
Probably have to come back with a better answer on that, Professor.
Okay, thank you. Okay, so I think this sound that only my question. So, and other the participant, have you any question for the Dr. Jagadan? I think no question. Yeah. Okay, Dr. Sika, you have any
Yes,
question?
thank you. Thanks for this. So I have just one single doubt, Mr. Shravan. Because here ROC curve analysis, it can be misleading. And that too when we are having imbalanced data set, because it may present an overly optimistic view of model performance. So what measures that you have taken to avoid such type of misleading imbalanced data set to be included in your curve analysis?
Can you hear me?
Yes, we can hear you.
So asking about the ROC curve analysis.
Yes, and
can
that
be
too
misleading.
because because it is generally sometimes it is misleading, and as we
Correct.
all know, because of that imbalanced data set. This is one of the
Correct.
characteristics of this ROC curve analysis.
That's
So,
correct.
what measure that you have taken to avoid this?
I mean, obviously, why ROC curves can be misleading is because of the data set and obviously various, model results. And whatever true positive rate or false positive rate and all. So the measures I currently took care is the precision recall curve, which I mentioned in my paper. And what exactly is it is the positive prediction and the ability to find all positive sample. And why it helps in the example where I provided is that could be whether it reveals a model prediction which are unreliable, or there could be something which are completely hidden. And for imbalanced data set, normally I've used a better indicator or strong model that has a high AOC or ROC. And obviously the F1 score I used, and obviously there is one more called confusion matrix that I have used. So these are the three measures I took care, which is the precision recall, F1 curve, and obviously the confusion matrix.
Okay.
Back to you, ma'am.
Yeah. Thank you. Thanks for answering this question. That's all from my side, Ms. Aparna. You can please proceed.
Thank you so much, sir and ma'am, for the wonderful presentation as well as the wonderful questions. Now, moving further to the next paper title, that is Android Ransomware Detection Application Using Deep Learning, under the paper ID 315. Sir Chuck Shai-So-In, I would like to request you to start with the presentation.
Okay. Hello, my name is Pet Im Thong Kam. Due to Professor Chakshai So-In has the session chair of another session. That's why today I am a representative of the presenter that this paper. Okay, I'm a co-author of this paper. Okay. Wait a minute, I will share our screen. Okay, do you see my screen?
Yes, sir.
Okay. Hello, everyone. I'm Dr. Phet Im Thong Kam from KK University, Thailand. Today, I will present our research about the Android ransomware detection using deep learning. This project is we contribute the real Android application and combine with the machine learning to detect a malware and the ransomware inside the APK files. Okay, first of all, we will take a look on the background. Usually Android application have the security challenge because the Android is when the market is up to 40% of the share market, but the Android is the open source base. That's why they have the some of the vulnerability like the ransomware in the Android. And this project we will try to use a deep learning technology to detect the malicious application in the Android APK files. Okay, for the research methodology, first of all, we train the datasets by using the Android malware dataset like the Invest Android malware the 2019 to do the static analysis, and we use the CCC, CIC Android malware 2020 for the API core data for the dynamic analysis. Then we try to do the data preprocessing by using min-max normalization and feature selection technique with SMO to address an imbalance issue. And for the model training, we develop an ensemble models to combine between the DNA and CNN to enhance malware classification efficiency. For testing and prediction, we conduct the static analysis and dynamic analysis by using the API core in the virtual environment. And for the model evaluation, we use the confusion metric and 5-point of the code validation to measure the accuracy, precision, recall, and F1 score. Okay, for the system overview, when you see the system overview for the statistic analysis, we embed the deep learning model to extract the permission access of the data to check for the ransomware characteristic and display the result immediately on the device screen. And for the dynamic analysis, we use the deep learning model in the server side. We call the server side, it's a sandbox server to test the application in the virtual environment for a set of time period to track the API call with result to send back to the user device. For the statistical is instantly running in the mobile device, but for the dynamics, we need to send the sampling into the sandbox server before. Okay, for the application development, we develop the real application by check the install app and scan the install app and to check the dangerous app. And we do the server analytics, okay? This is the application interface that we show. The first of all is the screen of the application. Then the application can list the many APK file that install in this device. And if you want to check, we can send the APK file to the server side in the sandbox. In the sandbox, we use deep learning to detect the malicious or not malicious.